All right, next in our agenda is the keynote discussion entitled Adapting to Future Learning Demands, Machine Learning, What It Is and Why It Matters. For this session, we will have Dr. Muhammad Reza Beyzadeh, Chief Technology Officer at Rice Hill Data Analysis, and Professor Patrice Bossier, Professor in Computer Science, Healthcare Informatics and Analytics at International Medical University as our esteemed speaker, and Mr. Hasnain, manager from the RMU e-learning department, who will be the moderator. Now I pass the microphone to Mr. Hasnain to begin the session.
Thank you, Nurul. Can I confirm? Can you hear me?
Yes, we can hear you.
Okay, thanks, Prof. Patrice. And it's an honor to actually be a moderator for such a wonderful session. You know, the discussion topic is on adapting to future learning demands, machine learning, what it is and why it matters. And we have two distinguished guests. I will introduce first of all to Dr. Muhammad Reza Beyzadeh. Dr. Baik is an inspiring team leader in international education and R&D organizations in the field of artificial intelligence and AI applications, artificial intelligence applications. He has been designing and developing various intelligent e-learning systems during, I think, more than 30 years already. He is also a dedicated senior curriculum designer, content developer, MOOC user, lecturer, and trainer in fuzzy and temporal logics, semantic technology, data analytics, and data visualizations. His 30 years of experience, knowledge, and skills encouraged him to focus on working on various aspects of Education 4.0 to identify how artificial intelligence can help to lead and make it happen in general by designing, applying, and using algorithms, systems, and platforms since 2019. You can actually Google his LinkedIn profile and all that. And recently he joined Rice Hill as a Chief Technology Officer. And let me introduce our next keynote speaker, our own staff from IMU, Prof. Patrice Francois Browser. And he has earned his Bachelor of Computer Science, Master of Computer Science, and PhD in Computer Science from University Père Marie Curie, France in 1981. He received the national accreditation for full professorship from the French Ministry of Higher Education and Paris South University in 1996. He has been appointed professor in computer science at International Medical University in February 2020. And in charge of developing new undergraduate and postgraduate programs related to digital health and health analytics. Prior to this, he had been head of the School of Computing at Taylor's University and Dean of STEM faculty at International University of Malaya, Wales. And that's the introduction of our both valuable speakers. So let's start with Dr. Raza.
Hi, good morning, everybody. Thank you very much for inviting me for this event. And I hope with a very short presentation that I have, you have a little bit of idea about what is the future of education and medical domain with respect to AI. Can I start my presentation?
Sure, yes, Dr.
Okay, can you see my?
Yes, Doctor, we can see you and hear you.
Okay. All right. All right. Good morning, everybody. Today I'm going to cover AI and future of education in medical domain.
Sorry, yes? Doctor, to interrupt. I think you need to change the view display setting. Yeah.
Oh, yeah. The view is...
Okay, now perfect. Now perfect. Okay. Continue, please.
All right. As the Victor mentioned, in fact, I've been working in various domains of education and e-learning systems, and also subset of artificial intelligence, and also apply AI in various projects in medical domain. So the yellow descriptions or project that I did on medical application of AI, and the white one is more related to e-learning. So I don't want to go to each of them. I explain a few of them while I'm talking, but I just wanted to show you that within the last 30 years, I've been involved in e-learning and intelligent e-learning systems, as well as applying AI in medical domain. But anyway, if I want to start with this, in fact, graph, I would like to say that the more we move forward to technology, in fact, education, in fact, lag behind. The system that we have is very old. The traditional education system is very old, and we cannot catch up with the speed of improvement and development of technology. So we have social pain or gap soon in future that we cannot teach everything at the right time. And when students graduate from university, they don't know exactly what is the most advanced technology in the market. So somehow we have to, in fact, move to digital transformation of education system and move to a new way of educating people. And how we are going to do that, as I said, in the past we were using games, social media, social network, internet, online programming, as we are doing now for education, and even new systems like Coursera and many others. In fact, but these are passive learning. We have to move to active learning as well in future. Active learning or proactive learning are intelligent e-learning system and interactive and adaptive or personalized e-learning system. So I've been working on this area, and Education 4.0 demanding this type of education system for future, actually. So if I want to summarize the whole story of future of education, I would like to show you this picture that each individual student is capable of communicating with various platforms, technology, augmented reality, haptics, cloud, big data, analytics, Internet of Things, and everything. In any domain, especially in medical domain, most of these devices are useful. And then the core of and platform of this environment is dealing with the various techniques and algorithms of AI in different subsets. And basically, the whole system or the whole cognitive education system will allow every individual student to learn whatever they want to learn and whenever they want to learn, and at any depth based upon their previous knowledge and personal preferences and interests. So this is the future of education. So we are moving towards some sort of a personalized and intelligent adaptive system so that the student can learn based on their multiple intelligence and learning style and other dimensions. So if I want to summarize this idea for future of active learning, actually everything is very dynamic and unpredictable, because for each individual we may have different curriculum and very open to every aspect. The student can move to any direction and find the best material that they are looking for, and also play with it and simulate it and do whatever they want to do in order to learn more and in depth. As a matter of fact, if I want to summarize this type of education system, the education system should tell each individual student what is right to do and what is the right, how to do things right. And this is the most important objective of such system. So this system is very interactive at very smaller scale level, virus and bacteria and cell level. And then we can move to visualization and teaching and analyzing various organs and systems in human body. And also we can identify specific points on each individual element of the body, and using certain semantic technology method, which we developed it while I was in NEMOS 12 years ago. And we developed this one in order to help, in fact, medical students to navigate and see what are the signs and symptoms of each individual patient. And we could scan at that time, we had a device for digital autopsy, so we could scan different layers of the body of human, and we could tag them to different diseases and so on, and students could see exactly where a specific symptom on the bone or muscle or nerve or whatever other organ is there for individual that person, and they can learn how to analyze it and so on, and learn about how to deal with it. So that was very advanced at that time. Unfortunately, not many people could handle that one. So as a matter of fact, besides this visual and abilities for using augmented reality and virtual reality in order to interact with the visual elements of the body, we can deal with the data as well. Everybody heard about the data analytics or big data analytics and so on. And this is beginning of the story of artificial intelligence. And in education, AI and big data is playing a very wide role and very important role nowadays, at the same time in medical domain. So everybody moved to design intelligent platform for medical domain, agriculture, or any other sector. So, but before we move to a little bit more detail, what is machine learning? We have to elaborate a little bit on data, because data is the core for any machine learning or any application of machine learning. So unfortunately, the concept of data is very complex, and anyone wants to deal with the data, they should know so many aspects of the data. This slide shows you the 10 V's of big data, or various dimensions of data, in terms of size, in terms of, in fact, velocity, variety, veracity, and value, and validity of the data, variability of the data, venue of the data, vocabulary that individual use, or meaning of the vocabulary, and vagueness. So you can see every single data that you have, you can look at them and try to tag them, what type of data that you have and what type of feature those data have in that context. And after this, when we are going to move toward analytics or applying machine learning as advanced analytics algorithm, so we must know what data we need, or we must have, or we should have, or we could have, or we want. So this part is also very important. We cannot just dump data into any system like machine learning or any algorithm, then we expect magic. So we need to identify not only the feature of the data that we have, but also with respect to the objective of the project or target that we have, we need to identify which data is a must data to have, or should data to have, or good data to have, or want data to have. And this is the key point before we go to any analytics for any purpose, especially for medical domain, because it's very sensitive. Now, before we move a little bit to machine learning. First, we have to see the ecosystem of machine learning and AI and data science and so on. This graph shows you the ecosystem of each individual discipline and the interaction between these different disciplines. So, of course, machine learning is not part of AI, but data science is related to AI and machine learning, but also is related to visualization, but also is related to statistics and pattern recognition, data mining, and so on. So these are all confusing terms, and the relationship must be very clear for each individual to understand. And what are these terms, and what is the relationship between these terms? So if I want to focus on the concept of AI and machine learning, I come to this graph and I say artificial intelligence has many subfields, and one of them is machine learning, and machine learning has many subfields, and one of them is deep learning. At the same time, all of them are related to the big data analytics. You can use various subfields, machine learning and deep learning in big data. And enabling tech is cloud and any other processing power platforms like Hadoop and whatever. So I hope I could give you very clear idea about the relationship between these terms. And then benefit of using AI in medicine is very important, because in fact we can have informed patient about the situation of the body. We can reduce the mistake or in fact error, and we can reduce the cost of care and increase the doctor-patient engagement, and also providing contextual relevance in terms of understanding each other when they communicate with the patient and explaining their disease or whatever symptoms that they have. So if I want to briefly go to data analytics or conventional data analytics maturity level, there are different types of analytics from very low level, which we analyze what happened in the past, what was the reason, and usually we call it, in fact, business intelligence, for instance, if you apply it in business. And also, you try to understand the pattern in the past signs or data that are related to signs and symptoms of the patient. So this is one aspect of it, but in the higher level of analytics, we are moving to prediction and prescription. Prediction means we can predict that certain disease, for instance, is going to happen, for instance, cancer or Alzheimer or whatever. And also prescription, that we can say how we can improve it, how we can, what if something happened in future, if this symptom is seen in future, what will happen and what we have to do. So these are the typical questions that data analytics can answer at different levels of maturity. When we deal with the data, definitely we have to do visualization. As I mentioned too, we have various types of visualization and concept, but the story is what visualization and what visual components are important to be shown to the doctors in order to make decisions, and even at the higher level, they make policies. So designing the visualization and dashboard is also very important, not only for individual information, but also for hospital information, for the country information. Every single visual component matters, and there are so many methods in order to make that visualization, data visualization, very effective and useful. Now, we are moving to the main topic of this talk. The concept of e-learning is very important. The concept of machine learning is very important. In conventional programming, actually, we write a program and we feed the data to that program and generate results. This is very common. We have an algorithm, we feed the data inside and generate some result, like a function. But in machine learning, the story is a little bit different. We have samples of data and we run machine learning algorithm on those data and design a model, develop a model. And this model is acting like the program that we write in the traditional programming. So we generate actually a program in very layman terms. We generate a program or a function. Then this program, which has been automatically generated by machine learning algorithm, receive data and generate the result. This is the difference between conventional or traditional modeling and machine learning modeling. So I hope the difference is a little bit clear now for you. And if we elaborate it a little bit more, we can say we have different type of machine learning, supervised learning, which we have the data and sample data, and we want to figure out about the new data. Unsupervised learning, which we don't have any label data, we are not aware of any information about the certain objectives that we are looking for, and we have just data. We have to cluster them and understand what is the clustering in that data set. And also we have semi-supervised, which is a combination of these two, and reinforcement learning, which is somehow, in fact, very useful for, in fact, reasoning and feedback to the system and decide accordingly. So these are the typical machine learning types. And as you can see at the bottom level, so regression, classification, and clustering association are the common terms in all these, in fact, algorithm that we have. So each type of algorithm or method can be used for different applications. For instance, for housing price prediction, for medical domain, for, in fact, marketing, for text understanding or text classification, and so on. So you can see all of them are can be summarized into a few functions: clustering, classification, and regression and association as a result. And then we can use this information for various applications. We have so many methods of, in fact, dealing with supervised learning and unsupervised learning and other type of learning. Each of these algorithm or method has so many algorithms related to that one, and each algorithm is useful for specific data. As I mentioned, the type of data identify which algorithm is more useful to generate right result. It doesn't mean that if we run any algorithm on the data, any data, we get the result. So this is very crucial point in my maybe 20 years of experience in this field, that if you apply right algorithm on the right data, you may get right result. Otherwise, garbage in, garbage out. And this is another point I wanted to share with you. But anyway, so what is the prediction? So the concept of prediction. The concept of prediction I represented in this very simple graph. As a matter of fact, we can collect data, then we can clean it. Of course, this cleaning and preparation is a very long story, but assume that we remove all useless data and we identify the useful data. And then the machine learning algorithm try to identify patterns in the data. As you can see here, the pattern of the blue one is identified already, and the system that we developed, the model that I mentioned to you before, the model is capable of generating the same pattern with respect to the given pattern, using the new data. And this is the main concept, the basic concept of machine learning. So we can do a lot with this classification and identification of the pattern. But we can identify objects, we can identify the meaning of sentences, we can identify cancer, we can identify any patterns in the cells and so on. So these are the typical methods that we can apply in various sectors like medicine. So the next concept I'm going to show you very briefly, we don't have much time, is deep learning. Deep learning actually is based on neural networks. In the past, neural networks only could have 3 layers, and they had complexity in mathematical modeling of more than 3 layers. And then deep learning, in fact, DeepMind company introduced this deep learning and tried to find a way in order to increase the number of layers in a neural network in order to somehow solve more complex problems. So if you use this technology for a specific domain, is extremely powerful. And if you remember, I mentioned to you data preparation and so on. In this process, in this algorithm, in fact, we don't need that much to do that. The system automatically extracts features or patterns at a small scale, and then combine them together, like you can see in this face. So these are some elements of the corner of the face and so on. So it slowly generate the face and can identify the face. So that is the big difference between deep learning and normal machine learning. So in deep learning nowadays, especially in medical domain, we have many applications. We can identify tumors and then identify the trace of any disease, the blood flow, medical interpretation. We can even by deep learning, we can look at the picture and generate interpretation and actually write the text. And in other applications, we can look at the picture and write story about that picture by using deep learning. The scope is very wide. But anyway, this is one project I did a few years ago. I used fuzzy system. I model, this is for hand-mouse disease outbreak prediction, and I use fuzzy logic in order to model the reason of outbreak of this disease. So after I study almost about 50 papers related to this disease, in fact, I realized that rainfall, humidity, and in fact, temperature are the main reasons for outbreak of the disease. So I modeled this story related to Bintulu information I had, number of cases. So I managed to predict 75% correct. And that was very good breakthrough using, for instance, fuzzy logic. But many people in the past, they used the probability and Bayesian method and so on, but they failed because they didn't notice that the outbreak of this disease is directly related to the natural phenomenon like temperature and so on. You cannot go for probability. We have to deal with the real elements involved in outbreak. So that was another point I wanted to share with you. But if I want to conclude my talk, I would like to introduce or ask to set up a Center of Excellence for, in fact, your university. And this Center of Excellence is going to combine researcher, student, industry needs, and then all the data analysts would be able to deal with the real data and understand it and develop solutions and models for it. And this would be very effective for future of education because, as I mentioned at the beginning, in the future, education graduate must, when they graduate, must be aware of real problem that they have to deal with upfront. So this is the most important target to have this center in IMU as a pioneer of medical education, and especially now they are very interested in AI and machine learning. I believe this is a good solution for future success. Thank you very much.
Thank you, Dr. Muhammad Raza, for setting the foundation of and briefly explaining all concepts relates to machine learning, AI, neural network, deep learning. So can I invite now Prof. Patrice? Can you share your thoughts about the topic? And then we will have a question and answer, a discussion session. So I will request all audience, please post your question in the chat and we will take them in the following session.
Can you see my slides?
Yes, Prof, we can see and we can hear you loud and clear.
Okay, thank you very much. And Reza was talking mostly about machine learning, and so this is the data analytics part. I will focus more on the data aspect, data engineering aspect, and I will explain to you what it means. So first, I would like to just show you a slide about the different applications of AI, but yeah, sorry, I forgot about health data. So we have different kinds of health data. As you can see, they are very diverse, and they come in different formats, and it's very difficult to integrate all these data. This is one of the big problems that we will have in the future. Okay, so next, yeah, there are very different applications of AI in healthcare. Reza has shown you a few of them. So we have some drug discovery, for example, where we use a lot of AI now, and you see what happened with the vaccine for the COVID-19 was, in fact, it was discovered very fast, and mostly because we were using AI techniques to find the good proteins and molecules that we could use. Then, of course, you have heard about medical image analysis, medical diagnosis, and others. One of the important one that will be developed in the near future is the one on the left here, AI-assisted robotic surgery. And we have a connection with a British company.
Prof, you got muted. Can you please unmute yourself?
Yeah, I don't know what.
Go ahead. Okay.
Okay. And so with these companies, we will work on this aspect later. And then you have some others, medical risk prediction, fraud detection, and so on. I will not spend too much time on this. But this one is very important because you will see what the market is expected to grow from 2020 to 2026 in different aspects of healthcare. And you see that one of the biggest one is medical imaging and diagnostics, then patient data and risk analysis. But all of these, you see, the growth factor in the next 5 years is around 50%, 40 to 50%. So this is something that is to be considered. Now the challenges. So this is the important part of it, because we have a lot of algorithms that we can use, but before that, we have to check the data. And one of the problems is the data volumes. So you see, most of you are using megabytes, gigabytes, and sometimes terabytes. If you have an external disk, you can store 1 terabyte of data. But in fact, we need more. We have petabytes, exabytes, and so on. You see, so the amount of data is huge, and especially in the healthcare sector, because we, as you can see, genomics, for example, is something that is going to need a lot of data storage and also data manipulation preparation. Next, we have a problem with data quality. We don't have, we not only have a lot of data, but we have issues with them because especially healthcare data, they come from different backgrounds. They are processed by different kinds of people. Sometimes it's automatic when you use a smartwatch, for example, smart device. But sometimes it's written by hand first by some people in the hospital. And then they are converted to digital data. And this is a reason why we need to check all this data and do some data cleaning. Next, data integration is another big issue because As I told you earlier, we have a lot of different kinds of data, different data structures, data formats, and we need to be able to integrate all this data for the same patient so that we can make decisions. And this is like a puzzle, in fact, where we have different data coming from different sources. We need to clean them and then to integrate them. And then only we can apply some algorithms to see what happens. And this is a very big issue because, in fact, 80% of the work done by data scientists is dedicated to what we call data engineering, that is data collection, data cleaning, data organization. And only 20%, in most cases, only 20% is dedicated to data analytics. Okay? So this is why we need to be very conscious of this and think about it later. Okay, next, data organization. I told you earlier, we have different data sources. So we have to integrate all this data and we have to store and manage all this data. And this is where we see that the world has changed since the 90s, where we had only a relational database system. Then we were using data warehouses and data mining and OLAP. Now we are still using a relational database system, but we also use what we call NoSQL database system because we need to process different kinds of data faster, for example, for deep learning and machine learning in general. And in that case, the relational database system is not very well suited, especially for unstructured data. For example, images, long text reports from medical doctors, for example, emails. All this cannot be stored in a relational database system. And that's why we need some specific kinds of NoSQL database system. Then we have big data and we have Hadoop. And then we still have data warehouses. So all this must be mastered. And people who want to become data scientists, they must think of this. They can focus on data analytics, but they will need people to take care of the organization of the data sets. And sometimes we call it data architects. And this is a growing job. And that's not an easy one because you need to know a lot of things about data storage and data management. So my first conclusion is that data is the problem. Analytics, we have a lot of machine learning algorithms. We have deep learning. It's still changing, evolving, but we have algorithms that help us at the moment. But if we don't have data, we cannot give anything. And if data are corrupted or not well cleaned, if there are errors or incompleteness, then we cannot do anything. We cannot process, we cannot do data analytics. Second, AI will not replace medical doctors, at least not in the near future, because we have too many data. AI is helping now, but it's not good enough at the moment. Maybe in 5, 10, or 20 years, AI will be able to say, okay, this is the diagnosis. But at the moment, AI is only giving advice to the medical doctors, and they still have the final decision. And conclusion 3, there is a future for digital health specialists because, as you can see, we still have a lot of issues. And this is why IMU has invested these last few years in developing a master in health informatics and analytics. So this is the last part of my talk, and I will explain to you what it means. Master in health informatics and analytics. IMU has worked on this program for the last 3 years and 3-4 years. And I was recruited last year in order to develop this program and Bachelor of Digital Health that will be launched next year. So we have launched this program in September this year, September 2021. We have 14 students at the moment, and we have medical officers, we have pharmacists, we have people who are lab technicians, and also people who are in business and IT. So it's a nice mix of different kinds of people. And it's very interesting to have these people working together. So I will tell you later what it gives us, because we are still working on it. And the contents of this program, we have 2 semesters. The first semester is dedicated to mostly the core subjects. That is health system and informatics, which is an introduction to health system, basically. So it's not specifically IT, in fact. It's how health systems are managed in a country like Malaysia and other countries as well. Then we start with data collection preparation, which is what I called earlier data engineering, data cleaning, data preparation, data organization. Then we have data analytics and data management before we start research methodology and scientific writing. So we have 4 core subjects. We have 2 electives, and in the second semester, we have 2 core modules and a research project, 10 credits for a 6-month research project. In fact, this research project can be, it can be research, but it can be also industry oriented, because most of the students that we have are working adults, and sometimes they prefer to work on something that they already know at their workplace, in fact. So I said we had 2 specific electives here, and initially we were thinking of offering a lot of electives to the students, but because of the background of the students, we in fact asked them, all of them, to take these 2 electives here, statistics thinking for health analytics and introduction to computer science and programming, because if students don't have this background, these 2 backgrounds, then it would be difficult for them to follow the core modules. So later, maybe in next intakes, if we have students coming from a background in computer science, mathematics, and this kind of thing, they might be able to take other electives. But for the moment, our students are taking these 2. So this program is open to not only science students or science people who are working in the science area. In fact, we have 3 students who are more into business and IT, and so this is a challenge sometimes for them, because of they don't have a background in statistics and programming. But it's open to all these people, and I think it's very good to mix different kinds of people like this. And after that, it's open to professionals, graduates from various areas. I told you business IT, for example, not only the healthcare sector. And we have health and social care practitioners, we have medical officers, we have pharmacists, and so on. And as I told you, we have 2 special electives, 2 prerequisites that students have to take at the beginning if they don't have a background in this domain. Okay. So I've added a few references in my slides that you can check later, because there are a lot of papers now available in some quite prestigious review journals. For example, in the Lancet, you have some articles in British medical journals, Nature, you see. And so this is important to see what's happening, because it's changing very fast, in fact. In the next 5, 10, 20 years, digital health will evolve a lot, because it will follow the evolution of AI. And there will be a lot of progress in both areas. But we have to be very conscious that the big issue is with data, because we are, in fact, we are dealing with the lives of patients. So we have to be sure that the data we have about these patients are good enough. And another aspect is security of these data, because we don't want, in fact, it already happened in some hospitals, for example, some companies, data was stolen, and you don't know what people are doing with it. Probably they are selling this data to insurance company, for example, or people who want to do something to attack you in some way, or to scam. So this is important to be conscious of this. Okay, so this is the end of my talk, and I'm open to any questions now. Thank you very much, everyone.
Thanks, Prof. Betis, for putting the analytic part, and how it's important to address that, right? Can I invite Dr. Raza also? And the floor is now open for question and answer and discussion. So, dear participant, feel free to type in the chat or just request a mic, and our technical team will give you the mic access. You can ask questions. Yeah. There's a first question from Associate Professor Dr. Nilesh Kumar regarding what level is MOH presently have we reached forecasting or predictive modeling? Is question addressed to Prof. Raza?
Basically, for the time being, I have no idea, but the time I was doing that project, it was 2016. At that time, was very advanced, and they didn't have any system to predict automatically. But within that few years, I have no idea what we have done. But more likely, they haven't done anything. I haven't heard anything since then. But anyway, if we want to know more about the current situation, maybe we have to refer to their site and so on. But I haven't seen anything.
Yeah, Prof. Patrice, if you want to add on this.
I'm not sure. I don't have many connections at the moment with MOH, but from what I heard from people we are working with, some companies, we are not there yet. Now, I think the MOH is working on trying to develop the electronic health record, EHR and EMA, and to make it possible to integrate data sets and to get the data about someone in one place. This is the first problem, I think, before we can work. In some places, in some hospitals, research labs, universities, people are already doing predictive modeling and forecasting. We have some colleagues in IMU who are doing this. And for COVID-19, people are doing it already. But in general, I don't think the MOH is that advanced at the moment. If someone from the MOH is there, maybe they can they can tell us.
Okay, thanks for addressing this question. We have another question from Paul Vishna. Who determines the outcomes of analytics? For example, in personalized medicine, is it the patient, the healthcare practitioner, or the provider, like the institution, relates to autonomy and perhaps ethics of practice? Yeah, very, very important question. Yeah. Yes, open to both of you.
Okay, Prof, go ahead.
You passed the question.
The outcomes of analytics. I think there is one basic thing in when we work in computer science, computing in general, is that you work with final users, what we call final users. In our case, we work with medical doctors, surgeons, and all these people, and they are the ones who tell us what they need, what they want. We cannot decide what is the outcome ourselves. It is, in fact, it happened in the past. It still happened, I believe, in some companies where the computer scientists believe that they know everything and they will decide. But it's very wrong. In fact, the outcomes have to be decided by the users themselves.
Can I add something?
Yes, please.
Actually, one of the very fundamental issues even now, most of the data scientists and organizations dealing with analytics facing, actually is who is going to identify the problem and who is going to compile or translate the problem into use cases for data scientists with a clear objective. His job is very crucial now. Those many people who are subject matter experts, they can identify the problem. Those people who are data scientists and they know how to use algorithm and write codes and so on, they know how to write programs to deal with certain use cases. But who convert those problems or translate your problem into use case, this is the maybe missing point. So I believe we have, that's why Center of Excellence is very important, because the team should work together in order to translate problems from medical domain, for instance, predicting this disease, predicting this one, another situation, outbreak, whatever. We have to translate it into use cases for data scientists to find a solution. So that is maybe a little bit more to the answer of the process.
Yeah, so in other words, you are saying like all medical doctors or some of medical doctors should be data scientists also, so they have medical domain knowledge.
Not exactly, but at least they should be able to communicate. Because when I was studying artificial intelligence, one of the courses I was passed was knowledge acquisition. Our job is to go to the experts and extract their knowledge. But nowadays, even those people who are going to talk to us, if they know a little bit of now our concern, then this communication is faster and better and more efficient.
Yes.
Yeah, in fact, it's one of the main outcomes and one of the main ideas we had when we decided to launch this master program, because we don't think that many, a few of them, but not all of those students who are attending, they will not become all of them data scientists, but at least they will have the basic knowledge to understand and to be able to communicate with data scientists, and they will understand how it works and what they can do with it. So this is a very important point.
Yeah.
Exactly. Yes.
That's great. That's great. Sorry to cut you because we have few more questions, and we have a question from Professor Zabidi. What do you think of the most urgent digitalization need in IMU based on your observation so far, and how do you think we should move in stepwise manner? So this question mostly addressed to Prof. Patrice, but Dr. Raza can add also.
Yeah, I think we should move forward very fast on the Center for Digital Health, because I've attended 2 meetings, I think, last year. Because of the pandemic, it has been postponed, but I think this is something that we should consider very fast, because other universities are moving fast as well, like Monash and Sunway, for example. For the moment, we are first. We have developed a master program. We are launching a bachelor in digital health next year. We have opportunities. IMU can, it's already a very well-known university, but we can become well-known in university in terms of digital health, health and health informatics in general. So this is an opportunity. Otherwise, there are many areas that we can think of about digitalization, but it's more traditional. This one, digital health, we have to think about it, and we have to be very careful where we go, because it's a complex topic. But this is my my idea at the moment.
Yes, any quick words, Dr. Raza?
Yes, I agree with Prof. In fact, we need to move toward digital transformation program. So we have to plan for it. Nothing happen, in a random way. We have to plan for it, how to reach to certain targets. And we have gap analysis, we have to go for maturity analysis and so on, in order to figure out where are we now and where we want to be in future. And that is the most important thing that we have to consider.
Yeah, and we have another question from, I think, Dr. Jitendra, and he's asking, like, will it be mandatory for all science/health educationists to embrace the knowledge of algorithm, coding, skills like machine learning, to upskill to match the upcoming generation students who are well versed in primary education? How to prepare oneself to match the future generation expectations?
My answer is very simple. Enroll in the master program.
Okay.
In fact, the program is fully online. For the moment, it's not ODL, because we need to have finished 1 year when we get the full accreditation to propose it as an ODL fully on. But it's already fully online. In fact, because of the pandemic, we have prepared all the contents online, and all our classes are done online. Yeah. So, and I think this is what people need. They need to have this basic knowledge. They will not need to be software engineers to know exactly how to do the programming, big programs, but at least to understand the basics, to be able to do simple programs in Python, for example. You can do it very easily. Regarding algorithms, I think it's changing very fast. Because if you see what companies like Google are doing, they are developing some kind of black boxes where the algorithms are put, and then you explain your problem in some way. You explain your problem, your case study, and then they will tell you, you should try this one, you should try this one. So it becomes, you have AutoML, and now they have what they call DevOps and all these things. It's becoming very advanced, very fast. And you have to follow what companies like Google are doing to see what will happen in the near future. But it's important to understand that there are different kinds of algorithms, of course, but mastering them, I don't think it's one of the basic skills.
Yeah.
One sentence. I usually say AI cannot do magic, and also nobody should be a magician. So I believe everybody, like this phone or computer, everybody can use now. We must know how to use it and what features do they have. Then we can communicate with the experts, data scientists and data engineers, to communicate with them idea and understand the challenge and try to find a solution together.
Yeah, so due to the time, I will just take one last question from Dr. Nilesh. He's asking like evolution of database management. And is it possible that Malaysian universities on their own, without the help of industry, can proceed with database management, like big data and all that, and with their own research data generated out of research? Prof. Pettis, maybe you go first.
Okay, from what I've seen, I've been in Malaysia for 19 years now, and I've worked with many different universities. And from what I've seen the last 6 years, most 6-7 years, the IT departments are not that strong that they can master everything usually. They can manage database system, but when it comes to big data and other kinds of solutions, I'm not sure. And I could see that quite often people were asking outside companies to work with them and to provide help. Like we are working with FusionX, for example. And in the future, it's always a question for all universities. It's a basic question. Even in France, when I was in France, in University of La Rochelle, it was not a big university. We had 7,000 students, but the university decided to have its own strong IT department, and they were developing their own software. But it's a specific case. Many universities, they have the knowledge, okay? They are able to talk to external companies, but if you want to work with Oracle, for example, you will need to buy Oracle, you install it, you manage it, but you still work with companies. With big data, it's changing. Now we have cloud also. So you need to master, you need to understand everything. And when you work in computer science, when you teach students computer science, architecture of a data system is something that is becoming very important, very complex, but very important.
Yes, Dr. Raza, last few words.
Yes, I believe in future, maybe within 10 to 20 years, everybody should be able to use these tools on cloud or anything for analytics and so on, like any software that every day we use, like Microsoft and so on. Everybody would be able to use it. And the knowledge, I'm consulting to one university in Ireland. They are working on how to introduce AI and data analytics and so on from school to students. So I believe, like mathematics, data science is very fundamental for everyone in future. So I'm sure in 10, 20 years, all graduates will be very aware of data science and all tools available on the cloud, for instance, and they are very friendly with these tools to deal with their data. That is the future I can see.
Thanks. I think I regret to actually cut down here because the discussion was going very nice, but due to short of time, and I would like to thank everybody. And just to quote few sentences from both the presentation. First one is like right data, right algorithm, right result. That's the thing I think we should all stick in front of us before jumping into these platforms and all that. And the other thing I would like to highlight, just now Dr. Raza was highlighting, like the development in software as a service, is coming up. So you no need to invest too much. You just need to, like just now Prof. Pettis was also highlighting about Google, so like black boxes, concept where algorithm will be managed by experts. You just, I don't want to use the word dumb, but you share the data to these algorithms and they will produce results to you, and you could actually analyze and visualize that data and make decisions, right? So thanks everybody for a very wonderful session, and thanks for the questions and sharing, So back to Nurul, MC.
Thank you very much.
Thank you. Thank you very much.
Thank you.
Right.
Thank you, Dr. Muhammad and Professor Bosir, for the wonderful sharing. That was a very interesting session indeed. And thank you, Mr. Hasnai, for moderating the session.